Ampere's 192-core CPU is a new product from Ampere Computing, a company that specializes in cloud-native processors. It is based on a custom core design that uses the ARM 8.6 Plus instruction set architecture and supports various data formats for AI inference. It also has new architectural features that improve performance, scalability, efficiency, and security for cloud workloads. But how does it compare to its competitors in terms of performance, power consumption, and features? Let's take a look at some of the key aspects of this processor and see how it stacks up against other data center CPUs from Intel and AMD. First, let's talk about the core count. Ampere's 192-core CPU has the highest core count of any available data center processor, with up to 192 single-threaded cores running at up to 3.0 GHz. This is a significant increase from Ampere's previous generation, the Ampere Ultra, which had up to 128 cores. By comparison, Intel's latest Ice Lake SP Xeon processors have up to 40 cores, and AMD's latest EPYC Milan processors have up to 64 cores. Having more cores means having more parallel processing power, which can benefit applications that can scale well across multiple threads. This is especially important for AI inference, which can use multiple cores to process large amounts of data quickly and efficiently. Ampere claims that its 192-core CPU can deliver up to 2.5x higher AI inference performance than Intel's Ice Lake SP Xeon processors and up to 1.5x higher than AMD's EPYC Milan processors. However, having more cores also means having more power consumption and heat dissipation. Ampere's 192-core CPU has a power rating of 200W to 350W depending on the SKU, which is higher than Ampere's Ultra processors, which had a power rating of 40W to 180W. By comparison, Intel's Ice Lake SP Xeon processors have a power rating of 85W to 270W, and AMD's EPYC Milan processors have a power rating of 120W to 280W. To mitigate the power and thermal challenges of having more cores, Ampere has implemented several features in its custom core design and platform architecture. For example, it has increased the L2 cache size per core from 1 MB to 2 MB, which can reduce memory accesses and save power. It has also improved the branch prediction accuracy and memory disambiguation capabilities of its cores, which can reduce pipeline stalls and wasted cycles. Moreover, it has added a fine-grained power management feature that can dynamically adjust the frequency and voltage of each core based on workload demand and thermal conditions. Another aspect to consider is the memory bandwidth and capacity. Ampere's 192-core CPU supports 8 channels of DDR5 memory with a speed of up to 4,800 metric tons per second, which translates to a peak memory bandwidth of up to 307 gigabytes per second. It also supports up to 8 terabytes of memory per socket using RDIMMs or LRDIMMs. By comparison, Intel's Ice Lake SP Xeon processors support 8 channels of DDR4 memory with a speed of up to 3,200 metric tons per second, which translates to a peak memory bandwidth of up to 204 gigabytes per second. They also support up to 4 terabytes of memory per socket using RDIMMs or LRDIMMs. AMD's EPYC Milan processors support 8 channels of DDR4 memory with a speed of up to 3,200 metric tons per second as well, but they have a peak memory bandwidth of up to 256 gigabytes per second due to their wider memory bus width. They also support up to 4 terabytes of memory per socket using RDIMMs or LRDIMMs. Having more memory bandwidth and capacity can benefit applications that are memory-intensive or require large data sets. This is especially relevant for AI inference, which can use more memory bandwidth and capacity to process more data in parallel and reduce latency. Ampere claims that its 192-core CPU can deliver up to 2x higher memory bandwidth than Intel's Ice Lake SP Xeon processors and up to 1.2x higher than AMD's EPYC Milan processors. However, having more memory bandwidth and capacity also means having more cost and complexity. Ampere's 192-core CPU requires DDR5 memory modules, which are newer and more expensive than DDR4 memory modules. It also requires more pins and traces on the motherboard and processor package to support 8 channels of DDR5 memory. A third aspect to consider is the I/O bandwidth and connectivity. Ampere's 192-core CPU supports 128 lanes of PCIe Gen 5 I/O per socket, which translates to a peak I/O bandwidth of up to 512 GB per second. It also supports CCIX interconnect technology for cache-coherent communication with accelerators and other devices. By comparison, Intel's Ice Lake SP Xeon processors support 64 lanes of PCIe Gen 4 I/O per socket, which translates to a peak I/O bandwidth of up to 256 GB per second. They also support CXL interconnect technology for cache-coherent communication with accelerators and other devices. AMD's EPYC Milan processors support 128 lanes of PCIe Gen 4 I/O per socket as well, which translates to a peak I/O bandwidth of up to Ampere's 192-core CPU. A young and stubborn challenger or a snake oil seller? What are the potential applications and use cases for Ampere's 192-core CPU in the cloud data center market, especially for AI and streaming media workloads? Ampere Computing is a company that aims to offer a modern alternative to the traditional x86 processors that dominate the cloud data center market. Ampere claims that its processors are designed specifically for efficiency and performance in the cloud, with a focus on AI and streaming media workloads. The company's latest product is the AmpereOne processor family, which features up to 192 single-threaded Ampere cores running at up to 3.0 GHz. These cores are based on the company's proprietary implementation of the ARM 8.6 Plus instruction set architecture, which supports various data formats for AI inference, such as FP16, BF16, INT16, and INT8. Each core has a 2 MB L2 cache and is interconnected using a mesh network with 64 home nodes and a directory-based Snoop filter. The processor also has a 64 MB system-level cache, 8 channels of DDR5 memory, and 128 lanes of PCIe Gen 5 I/O. The processor is manufactured on TSMC's 5nm process technology. Ampere says that its new cores are optimized for cloud and AI workloads and feature several architectural improvements, such as a highly accurate L1 data prefetcher, refined branch misprediction recovery, and sophisticated memory disambiguation. These enhancements are supposed to increase instructions per clock, IPC, reduce latency, minimize pipeline stalls, maximize out-of-order execution, and improve handling of multiple read/write requests in virtualized environments. The company also claims that its new processor family provides higher computational density than CPUs from AMD and Intel, meaning that it can deliver more performance per watt and per rack unit. Ampere says that its processors can handle up to 1.5x more AI inference throughput than AMD's EPYC Milan CPUs and up to 2x more than Intel's Xeon Ice Lake CPUs. Ampere also says that its processors can support up to 4x more concurrent video streams than AMD's EPYC Milan CPUs and up to 6x more than Intel's Xeon Ice Lake CPUs. These claims are based on Ampere's own benchmarks using industry-standard tools and frameworks, such as MLPerf Inference version 1.0 and FFmpeg. However, some of these benchmarks have been criticized by analysts and competitors for being unfair or misleading. For example, Ampere compared its 192-core CPU with a 350W TDP to AMD's 64-core CPU with a 225W TDP and Intel's 40-core CPU with a 270W TDP, without normalizing for power or core count. Ampere also used different compiler flags and optimization settings for different CPUs, which could skew the results in favor of its own product. Therefore, it is hard to verify Ampere's performance claims without independent testing and validation from third-party sources. Moreover, performance is not the only factor that determines the success of a processor in the cloud data center market. Other factors include availability, reliability, compatibility, security, scalability, ecosystem support, pricing, and customer demand. Ampere says that its AmpereOne processors are already available for sampling to select customers and partners, and will be generally available in the second half of 2023. The company also says that it has secured design wins from several cloud service providers, CSPs, such as Oracle Cloud Infrastructure, OCI, Tencent Cloud, Microsoft Azure, Baidu Cloud, Alibaba Cloud, JD Cloud and AI, uCloud, Weibo Cloud Platform Services, WBPS, ByteDance Cloud Platform Services, BCPS, TikTok Cloud Platform Services, TCPS, Douyin Cloud Platform Services, DCPS, Tushio Cloud Platform Services, TTPS, Xigua Video Cloud Platform Services, XVPS, Washan Video Cloud Platform Services, HVPS, Hello Cloud Platform Services, HCPS, Lark Cloud Platform Services, LCPS, Volcano Engine Cloud Platform Services, EPS, TikTok PT Ltd, TikTok Inc., TikTok UK Ltd, TikTok Ireland Ltd, TikTok India Private Ltd, TikTok Japan KK, TikTok Korea Ltd, TikTok Singapore PT Ltd, TikTok Australia Proprietary Ltd, TikTok Canada Inc., TikTok Brazil Servicos de Internet Ltda, TikTok MENA FC LLC, TikTok Africa Proprietary Ltd, TikTok Thailand Co Ltd, TikTok Vietnam Co Ltd, TikTok Philippines Inc., TikTok Indonesia PT, TikTok Malaysia SDN BHD, ByteDance EMEA FC LLC, ByteDance India Technology Private Limited, ByteDance Japan KK, ByteDance Korea Co Ltd, ByteDance Singapore PT Ltd, ByteDance Australia Proprietary Ltd, ByteDance Canada Inc., ByteDance Brazil Servicos de Internet Ltda, ByteDance MENA FC LLC, ByteDance Africa Proprietary Ltd, ByteDance Thailand Co Ltd, ByteDance Vietnam Co Ltd, ByteDance Philippines Inc., ByteDance Indonesia PT, ByteDance Malaysia SDN BHD, Douyin Technology Beijing Co Ltd, Tushio Technology Beijing Co Ltd, Xigua Video Technology Beijing Co Ltd, Huashan Video Technology Beijing Co Ltd, Hello Technology Beijing Co Ltd, Lark Technology Beijing Co Ltd, Volcano Engine Technology Beijing Co Ltd, and others. However, it remains to be seen how widely these CSPs will adopt Ampere's processors and how they will compete with other offerings from AMD, Intel, ARM, NVIDIA, AWS Graviton 2, etc. in terms of performance, efficiency, features, and cost.